Hey everyone, hope you're doing well today. In this video, let's go over integers with rational numbers. And this is kind of just a little answer key for the study guide to help you get ready if you're trying to finalize your understanding of integers and rational numbers as a whole. Okay, so for these first set of directions here, let's see what it says. Fill in the blank for each of the sentences with either always, sometimes, or never to create a true statement. Okay. So for this first one, it says a negative number plus a negative number is blank a positive number. So let's try to give an example here. So if we give like a -3 plus like a -2, well, that's two negatives together. And if you had two negatives, that would just be another negative number, right? So if you had two negatives, you can try to come up with another example, but you're always going to get a negative number. So in terms of this answer, what we're going to write here is we're going to write it's never going to be a positive number, okay? So a negative plus a negative is always negative, so it is never positive. For the second one, a positive number minus a positive number is blank a negative number. So let's take a positive number like, I don't know, 7 and then take away 2. Well, 7 take away 2, that's 5, and that's positive. So I'm wondering, is it possible to make it negative? Well, if we said 2 minus 7, that would be -5, right? So it could be either or, it kind of just depends on which one's farther from 0. So in this case, if it depends, we can say sometimes. All right. Okay, cool. For letter C, a negative number minus a negative number is blank a positive number. So a negative number like, I don't know, like -8 minus a negative number like -10. Well, if you keep change flip, this ends up being -8 plus 10, so that's going to be +2. But what if we have like -8 minus -1? So if we go ahead and do that, then it's going to keep change flip. That would be -7. So I guess in this case, a negative minus a negative also can be sometimes a positive number, but sometimes it doesn't have to be. Okay. For letter D, a positive number minus a negative number is blank a positive number. So a positive number, how about like 10? And then let's take away a negative number like -3. Okay, so if we keep and then change and flip, it's the same thing as 10 plus 3, that's going to be 13. I'm trying to think if it's possible to get ever a negative number, and I don't think so, because we're always going to end up adding a positive no matter what. So this is going to be always positive. Okay, moving down just a little bit here. For letter E, we have a negative number multiplied by a positive number is blank a positive number. Let's see, so if we have like -4 multiplied by 7. Well, 4 times 7 is 28, and I see one negative. That means the opposite, so the opposite of 20 is -28. So a negative times a positive, that's always going to be a negative, so it's never going to be positive. Okay, remember with multiplying and dividing, it never is going to be sometimes. Multiplying and dividing, it's always going to be positive or negative, depending on what you're multiplying or dividing by, but there's no it depends or there's no sometimes. For letter F, a positive number divided by a positive number. Let's see here, like, I don't know, 10 divided by 2, that would be 5. And you've divided positives many, many times at this point, so that's always going to be positive, so it's never going to be negative. Okay, and then finally for letter G, a negative number divided by a negative number is what? So if we do like -20 divided by -4, that's actually going to be a +5, because think about it, 20 divided by 4 is 5, and then you have two negatives, so the opposite of 5 is just going to be 5, so this is always going to be positive. All right, moving down to number 2. The directions here say rewrite each of the sums as differences and then evaluate. So notice how all of these problems have an addition sign, and so that's why these are sums, and the directions say to rewrite them as differences. So that means we need to keep, change, and flip, or add the opposite. So if we saying 8 plus -3, again, that's equivalent to saying 8 minus 3, and that's going to be equal to 5, right? Just another way of thinking about it. We can rewrite all addition problems as subtraction problems. For letter B, if we do the same thing and we use the inverse operation and use the opposite, we can keep and then change and then flip. we're going to end up with 4 here. Okay. For letter C, if we keep this, then change this and flip this, we can write an equivalent statement of saying 14 minus 23. And if 23 minus 14 is 7, then 14 minus 23 is negative 7. Okay. And then finally, for letter D, if we want to rewrite this as a subtraction problem, we can write this as negative 25 minus 23. And arguably, this one's maybe more difficult to understand by changing it. This will be negative 48. So again, you can solve it using whichever one you prefer. For letter D, probably the original one is easier for most people, but you should get negative 48 either way. For number 3, we are going to rewrite each of these differences as sums and then evaluate. So notice how for each of these we have a subtraction as the operation, and we're going to rewrite them using addition. So we're going to keep, change, then flip. So this is equivalent to saying 14 plus negative 3, and then that will end up just being 11, however you look at it. For this next one, we're going to keep this, change this, and flip this. This will be 8 plus a 7, and that'll be 15. For letter C, we're gonna keep this, change this, and flip this. And that's going to be negative 8 plus 13, and that'll equal 5. And then for letter D here, we're gonna keep, and then we're gonna add the opposite of this. So that's gonna be 23 plus 66, and that'll equal 89. All right, so again, for number 2 and 3, it's just practicing rewriting expressions using whichever one is easier for you, but it's important to feel comfortable going back and forth and solving either way. All right, moving on down to number 4, the directions here are to determine each of the following products and quotients. So products means multiplication, and quotients means division. So for letter A here, 63 divided by 9, that's just going to be 7. There's no opposites here. For letter B, 5 times 8 is 40, but there's 2 negatives, so it's the opposite of 40, which is just 40, so leave it alone. And then 20 divided by negative 4, well, 20 divided by 4 is 5, and there's 1 opposite sign, so it's the opposite of 5. For letter D, 6 times 3 is 18, and there's 1 negative, so 1 opposite, so it's negative 18. Letter E, 36 divided by 3 is 12, and there's 2 opposites, so the opposite of 12 is just going to be 12. And then for letter F, 8 times 6 is 48, and there's 1 opposite sign, so the opposite of 48 is going to be negative 48. Moving down just a little bit more here. Now we're going to evaluate each of the powers. Okay, so for letter A, what we're going to do here is say, okay, negative 2 times itself, excuse me, 4 times, that should equal positive 16 because there's going to be 4 opposites. But 2 times 2 times 2 times 2 is going to be 16. For letter B, however, we're going to get 16, but it's the opposite of that because there's 1 negative or 1 opposite at the end. Negative 3 to the 5th power is going to be negative 243. That's just because if you multiply 3 times 3 times 3 times 3 times 3, that these 2 3s make a 9, these 2 3s make a 9, 9 times 9 is 81. And if you multiply 81 times 3, you're going to get that 243. In this case, even if it's in parentheses, you're still going to get negative 243 because you're going to have 5 negatives. If you have the 5 opposites or the opposite of the opposite of the opposite of the opposite of the opposite, you'll still get a negative value, or the opposite of 243. For letter E, negative 5 times negative 5, that's going to be positive 25 because we have 2 negatives or 2 opposites. And letter F, you're going to get 5 times 5, which is 25, but there's 1 negative in front, so 1 opposite, so it's going to be opposite of 25. All right, let's move on to number 6, where we're dealing with some fractions. So we're going to evaluate, which means we're going to solve. And when it says rational number expressions, rational numbers just means like fractions and decimals or not whole numbers. Make sure we are going to write all final answers as either a whole number or a mixed number, so no improper fractions at the end. Alrighty, so let's give these a go. First things first, I would give the negative to the top, write it just like this, and then check to see that we have common denominators, which we do, which is good. So then we can go ahead and say negative 3 plus 27 over 4. And negative 3 plus 27, that should be 24. 24 over 4 simplifies down to just being a whole number of 6. Okay, so that's going to be 6a here. For letter B, let's see, I'm going to give that negative to the top, so it's negative 14 over 3 plus negative 37 over 3. And so they're both over positive 3, which is good. So you have negative 14 plus negative 37, both over 3. So if you add the numerators here, it's negative 40, negative 51 over 3, which happens to be negative 17, right? So if you know 5 plus 1 is 6, then it's divisible by 3. So 17 times 3 is 51. Let's try C here. So for C, we have 4/5, and then we're going to take away, and then let's move that negative to the top, so it's going to be negative 14 over 5. With subtraction, keep in mind that we can keep and we can change and we can flip this one. So if we do that, this is really the same thing as 4/5 and add the opposite, so it's going to be plus 14 over 5. And so 4 plus 14, I'm just going to add it here. That's going to be 18 over 5. And 5 goes into 18 3 times. 3 times 5 is 15 with 3 left over. So 3 3/5 should be our final. Alrighty. Moving on to letter D. Now for letter D, I'm noticing that this 14 and 21 can be divided by 7 right from the beginning, and that should make our lives a little bit easier. So that will give us, I'll go that negative to the top, negative 2, so it's negative 2 over 3 minus 4 over 5. So at least we have some smaller numbers to deal with. And I know 3 and 5 meet at 15, so that's going to be easier to get common denominators. I do want to kind of just turn it into an addition problem first. Negative 2/3 plus negative 4 over 5. And to make these both 15 on bottom, let's multiply it by 5 and 5 and multiply by 3 and 3. So that should be negative 10 plus negative 12. I'm just going to put it all over 15 because I know they have common denominators now. That's going to be negative 22 over 15. And 15 goes into 22 once with 7 left over. So negative 1 and 7/15 seems to make sense here. For letter E, we got some mixed numbers here. So let's see, if we multiply this 5 times 4, that'll be 20, plus 3 is 23. So I'm thinking this will be negative 23 over 4 plus, and then 9 times 6 is 54. 54 plus 5 is going to be 59. So that's going to be 59 over 6. Okay, so we have improper fractions here. The only problem is we don't have common denominators yet. So we have these improper fractions, which is good, but we need some common denominators. So 4 and 6, I think, meet at 12 for the first time. So I'm going to multiply by 3 and 3 on the left, and then multiply by 2 and 2 on the right. And if we do that, we're going to get negative 69 over 12 plus 118 over 12. So they are common denominators, so we can actually do something with the numerators here. So negative 69 plus 118 is the same thing as 118 minus 69, and that should equal 49 over 12, I believe. And 12 times 4 is 48, so 48 is 1 away from 49, so that's going to be 4 and 1/12. Moving on, let's try F here. For F, we're going to be multiplying. So if you're not sure where to give the negative, again, we give it to the top typically, so you can choose, but it's just usually just easier to do it to the top, or give it to the top number, okay? And so we're multiplying here. We should try to cross cancel if we can. I think 16 and 20, we can divide them both by 4. That'll be 4, and that'll be a 5. Then I'd like to maybe cancel out this 5 with this 35. Again, there's multiple ways to do this, but I'm just gonna make this a 1 and make this a 7. And I don't think we can do anything besides that. Okay, so if we multiply on top, negative 15, this negative 15 on top times this 1, that's going to be negative 15. Sorry about that. And on bottom, this 4 times 7 is going to be 28. So negative 15 over 28 should be this product here. For letter G, let's see, we have 18 over 10. We're multiplying this by negative 15 over 24, so keep in mind that parentheses just means multiplication here, okay? We got some, maybe some cross-canceling we can do, and so I'm thinking for 18 and 24, you can divide them both by 6, that'll be 3, and that'll be 4. And then it looks like maybe for the 10 and 15, we can say divide by 5, that'll be 2, and divide by 5, that will be negative 3. Don't forget that negative there, that might get you. And then on top, this 3 times negative 3, that's going to be negative 9. And then on bottom, this 2 times 4 is going to be 8. So as a mixed number, that's going to be 1, negative 1, and 1/8. Okay. That's it for letter G. Again, it's these multiplying and dividing ones are a little bit nicer in some ways because you don't have to deal with common denominators. For letter H, I'm just going to start by moving the negative up here. I'm not going to do anything else right now, and then we're going to divide this by 20 over 42. And then we're going to keep this, we'll change this, and we'll flip this. So then when we rewrite this, we'll have negative 15 over 28, and then multiply by 42 over 20. So in this case of flipping, we're doing the reciprocal, or flipping upside down, which is different than the flipping for the opposite. So just try to make sure you know the difference when we're subtracting and adding versus dividing with fractions, okay? All right, so if we're gonna go ahead and cross cancel, we can divide these two both by 7, that'll be 4, and this will be 6. And I think we can also cross cancel this by 5, that'll be negative 3, don't forget the negative, and by 5, this will be 4. Oh shoot, that means I could have canceled out more. Oh, I see now, this can be a 2, this can be a 3. That means, 42 and 28 could have both divided by 14 instead of 7. That's okay. Negative 3 times positive 3 is going to be negative 9. And then on bottom, 4 times 2 is going to be 8. Is it the same as last one? Negative 1 and 1/8? I guess so. Moving on to letter I. If we go ahead and multiply, 2 times 5 is 10, plus 4 is 14. This will be negative 14 over 5, divided by. And then 3 times 2 is 6, plus 1 is 7. This is divided by negative 7 over 2. All right, now if we want to keep this, then change this and flip this because we want to turn this into a multiplication problem. Then we can go ahead and do that. This will be negative 14 over 5 times 2 over negative 7. Again, it's okay, it depends on where you want to put the negative, but I happen to move it down here. If we divide both of these by, just say negative 7, we'll get a positive 2, and divide by negative 7, then we'll get a positive 1. So you didn't have to do that if you didn't want to. You could save that for later, but we should end up with the same answer either way, meaning we should both get a positive answer at the very end of the problem. So 2 times 2 is going to be 4 on top, and then 5 times 1 on bottom is just going to be 5. So we have a final answer of 4/5 here for our quotient. Finally, for this J here, we're multiplying 3 and 4/7 by negative 21/50. So we're going to do 3 times 7 is 21 plus 4. That's going to be 25 over 7 multiplied by negative 21 over 50. Okay, so we don't have to keep change flip or anything because it's a multiplication problem, but we should try to maybe cross cancel. This will be nice. That's a 1 and a 2. 25 is half of 50. And then 7 goes into 21 3 times. Don't forget to negative 3 though. And then 1 times negative 3 is going to be negative 3. And on the bottom, 1 times 2 is going to be 2. So at the end of the day, this is just negative 1.5. All right, cool. So if you made it through all those fractions, a really good job. That's impressive. Fractions can be a little bit trickier and more involved. So hopefully those made sense, or if not, you feel a little bit more comfortable with what to do. All right, let's try number 7, where we start talking about some order of operations problems. So don't forget the order of operations, no parentheses, no exponents. I do see multiplication here, so 2 times 5, that's going to be 10, so I'll be negative 4 minus 10. And I prefer to keep change flips, so I'm going to keep that, change that, and flip that. So it's really negative 4 plus negative 10, and I know that's going to be negative 14. Okay, for letter B here, I got to start by looking inside the parentheses before anything else, and negative 7 minus 4, I know it's the same thing as negative 7 plus negative 4 if I keep change flip. And so negative 7 plus negative 4 is negative 11. And if I do 2 times 11, that's 22. And I know it's the opposite of that because there's only one negative, and that's going to be negative 22. Okay. For letter C, let's see here. Start with inside the parentheses. Negative 3 plus 9, that's the same thing as 9 minus 3, and that's going to be 6. So it's going to be 5 minus, it's going to be 5 minus 6. I don't need the parentheses because there's only one thing left in there. 5 minus 6, that's the same thing as 5 plus negative 6. So if you prefer to keep change flip, that's up to you. But in this case, we're going to end up with, negative 1. Okay. For letter D here, it looks like we have some division, some subtraction, and some multiplication. So division and multiplication are equally important, so we'll go left to right with those. 16 divided by 8 is 2, but it's the opposite of that, so it's negative 2 minus 3 times negative 5. And then we have this multiplication problem here, so it's negative 2 minus, and what's 3 times 5? 3 times 5 is 15, but there's one opposite, so it's going to be negative 15. Okay, and then we have to keep and then change and then flip. And so this is negative 2 plus 15, or 15 minus 2, and that should equal 13. All right, there we go. For letter E here, let's see, we have exponents and there's no parentheses, it's just division at the end. Okay, so 3 to the third power, keep in mind that that is going to be 3 times 3 times 3. 3 times 3 is 9, 9 times 3, that's going to be 27. So this is going to be 17 minus 27 plus 20 divided by negative 4. Okay, so we'll start off with that. There's no parentheses. We took care of the exponent. Let's go on to division here. So 20 divided by 4, that is 5, right? But then we have one opposite, so it's the opposite of 5. So we're going to write negative 5 at the end. Then we have addition and subtraction, but they're equally important, so we'll just go left to right. 17 minus 27. You can keep change flip if you want, but I know it's just 27 minus 17, which is 10, and just make it negative. So I'm just going to go ahead and do that. Again, it's your preference. You don't have to keep change flip if it makes sense to you. And then negative 10 plus negative 5 is going to be negative 15. Cool. So that's E. Let's go on to F. For F here, we should start with parentheses over at the very end. So 48 divided by, I'm just going to copy this down. And then 1 minus 4, that's the same thing as 4 minus 1, but make it negative, so it must be negative 3, okay? And then let's see if we can deal with the exponent next, so that would be this negative 2 to the 4th power. So what is that? That's negative 2 times negative 2 times negative 2 times negative 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it's positive because we have 4 opposites. And 4 opposites means it's just normal again. So 48 divided by 16 minus 3 divided by negative 3. All right, we took care of the parentheses. We took care of the exponents. We have 2 division problems, and if they match, that's great. We can do them both at the same time. 48 divided by 16 is 3, and then 3 divided by negative 3. Well, 3 divided by 3 is 1, and it's the opposite of that, so it's 3 minus a negative 1. And then if we keep change flip here, 3 minus negative 1 or 3 plus 1 is the same thing as 4. That's letter F. All right, let's take a look at G, where we have some fractions to deal with here. So here, I think we have to start with this exponent. So this is negative 1/2 multiplied by negative 1/2. So pretend they're both positive or something for now, and then think about the negatives in a little bit. So 1 times 1 on top is 1, and then on the bottom 2 times 2 is 4. So it's going to be 1/4. And then there's 2 opposites, or 2 negatives, which means it's the opposite of 1/4, which is just 1/4. We're going to multiply this by 16, but I know when we multiply we need, improper fractions or proper fractions, so I'm just going to write a 16 over 1. And then now we have a multiplication, a subtraction, and a division. And multiplication, division are equally important. I'll go left to right. Looks like we can cross cancel. That's a 1. That'll be a 4. So we have 1 times 4 is 4. 1 times 1 is 1. So 4 over 1 is just going to be 4 minus 3/4 divided by 6/8. Now we're going to go to do this division problem. This is actually kind of interesting here, right? Because if you divide 6 and 8 by 2 and simplify it, you're going to get 3/4. So notice how this is really just 3/4 divided by 3/4. And anything divided by itself is just 1, right? So this whole thing just becomes 4 minus 1. So you can write out the algorithm for it or like do the keep change flip, but you're just going to end up getting 1 anyway. 3/4 divided by itself is just 1. Okay. Last but not least, letter H here. We're going to start off with the parentheses before anything else. So we'll look inside here. Okay. And we're subtracting. It looks like we can do some not cross canceling, but simplifying. 14 and 21, you can divide them both by 7. That'll be 2/3. And then 4 over 8 is the same thing as 1/2. Right? So before we do anything else, just know that those can be smaller. So that can just make things a little bit easier. So 2/3 minus 1/2 is really what we have inside there. And in order to subtract them, you need common denominators, right? So I multiply these to make 6 their common denominator. So that's going to be 4 over 6 minus 3 over 6, which is just going to be 1 over 6. All right, so a little bit more work, but we have negative 3/4 minus 2 times the quantity of whatever this 1/6 is squared. We just found out that that's 1/6. Next thing to do will be this exponent here. So that's going to be this 1/6 multiplied by 1/6. That's going to be 1 times 1 on top and 6 times 6 on bottom. So that's going to be negative 3/4 minus 2 times 1 over 36. Now we can't do subtraction, we got to do multiplication before anything else. So let's see here on the side here, 2 over 1 times 1 over 36. We can cross cancel because we're multiplying, so that's 1 and that's 18. And then if we multiply it out, that's going to be 1 over 18. So that'll be negative 3/4 minus 1 over 18. If we keep, then change, then flip and add the opposite, then we can just really add these and then simplify. So it's a negative plus a negative. We know it's going to be more negative. And when do 18 and 4 meet for the first time? I think that's going to be 36. So I'm going to multiply this by 9 and by 9, by 2 and by 2. So this will be, move the negative up, negative 27 over 36 plus negative 2 over 36. And that should be negative 29 over 36. I think that's it. Alrighty, let's check out the last section here, number 8. So evaluate each of the following variable expressions. We know that A is negative 2, B is 3, C is 4, D is 1/2, and E is negative 2/3. All right, so just a few of these. Let's see, A is negative 2, so we'll substitute that in. Always use parentheses when you're doing that. Multiplied by D, which is 1/2, plus what's B? B is 3, and then C is 4. So if we multiply this out here, well, what's 2 times 1/2? 2 times 1/2 is just going to be 1, but it's going to be the opposite of that because there's one of those. Since there's 2 multiplications, we'll just do them both at the same time, if that's okay. That'll be the next step anyway. So we have negative 1 plus 12, and that's going to end up being 11. Okay, so that's going to be 8A. And let's go on to checking out B. So for B, we have start off with B, which is going to be 3, times E, which is going to be negative 2/3, minus A, which is going to be, negative 2, so don't forget the extra negative, multiplied by B, which is going to be 3, minus 8. Okay, so we got to start off with parentheses first, which is going to be in here. And so, let's see, this is going to be 3 times negative 2/3 minus a negative 2 multiplied by, so 3 minus 8 is the same thing as 8 minus 3, but it's negative, so it's negative 5. Then we're going to go over here, If we do 3 over 1 multiplied by negative 2 over 3, these can cross cancel, and we'll be left with negative 2. So this will be negative 2 minus negative 2 times negative 5. Then we can go ahead and use this multiplication. So a negative times a negative is going to be a positive. So that's going to be positive 10, or the opposite of the opposite. And then finally, if we want to add the opposite instead or keep change flip, negative 2 plus negative 10 is going to be negative 12. For letter C here, let's see what we got. We got negative 5 multiplied by C. We know C is 4 minus the quantity of B. So B is what? B is 3 minus whatever A is negative 2. And then raising that to the second power. Okay, so for this one here, what we're going to do, I think we're going to go inside this parentheses first. So it's going to be negative 5 times 4, just copying this down, minus. And then 3 minus a negative 2, that just becomes 3 plus a normal 2. So 3 plus 2 is going to be 5. So it's going to be 5 squared. And then 5 squared, that's just 5 times 5, which is 25. So minus 25. And then 5 times 4 is 20, but it's the opposite of that, so it's negative 20 minus 25. And then we're going to, the same thing as negative 20 plus negative 25, so that's going to be negative 45. Okay, so that's what we're going to get in this problem using those values of variables. Okay. Finally, for the last problem, we have B multiplied. So B is 3, so 3 is going to multiply by what's E? So E is going to be negative 2/3. And we're going to subtract 1/2 from it. And then we're going to raise that whole thing to the third power minus the quantity A, which is negative 2, multiplied by E, which is negative 2/3. A lot of fractions. Okay, so we got to start with parentheses, so I think it's going to be right in here. And for me, I like saying keep, change, flip. And so what are we really trying to do here? This is negative 2/3, give the negative to the top, plus negative 1 over 2. And so if we get common denominators, we need to get 6, so I'll do times 2 times 2 times 3 times 3. So then this should be what? Negative 4 over 6 plus negative 3 over 6. So that should be negative 7 over 6. So I'm going to keep this as an improper fraction just because they're easier to use. So it's going to be 3 out in front. Negative 7 over 6 cubed is what we just got over there, minus negative 2 times negative 2/3. Okay, so far, what do we really have here? Well, at least we took care of the parentheses. I think this next part is going to be a little bit annoying, though. Just looking at it, we have this negative 7/6, and so on the side here, you can think about that as a negative 7 on top and a 6 on bottom, but we're multiplying by 3 of them, right? It's raised to the third power. So we have 3 in front multiplied by, and so 7 times 7, that's 49, and then 49 times 7 is going to be 343, but it's going to be negative 343, right? Just because they have 3 opposites. And then 6 times 6 is 36, and 36 times 3, it's going to be 216. All right, so that's what negative 7/6 cubed is, right? You remember you just multiply the numerators and denominators together, and minus negative 2 times negative 3. Now we do have 2 multiplication problems. You want to do them at the same time, totally fine. 3 is 3 over 1, then negative 343 over 216. Now 2 plus 1 plus 6 is 9, so it is divisible by 3. So that means we can cross cancel, which is kind of nice, so that's a 1. And I think that's going to be 72, right? Because 7 times 3 is 21. That matches perfectly. And then you have that 2 into 6. 3 times 2 is 6. Okay. So, hey, I mean, makes it a little smaller. Negative 343. And then need to use a calculator for that. Over 72 minus. And then, again, this is just 2 multiplication problems, so I'm just going to do them back to back here. Negative 2 is negative 2 over 1 multiplied by negative 2 over 3. So negative 2 times negative 2 is positive 4, and 3 times 1 is 3. So I think we have this negative 2 times negative 2/3 is just going to be a positive 4 over 3. Now for subtracting here, we can say keep, change, and then flip. And then now we really are looking at saying, can we add or subtract these together? It's a negative plus a negative, so we know it's just going to be more negative. But however, we do need common denominators. So just to make these a little bit easier, I know 3 times 24 is 72. And so if we go ahead and do that, I'll take this negative 343 over 72 plus, and this should be negative 96 over 72. And so 96 plus 343, since they're both negative, we're just adding. So it can be negative 439 over 72. And this should be a mixed number. Let's see. 439 divided by 72. 70 times 5 is 350. 70 times 6. I feel like I want to try 6. 72 times 6, that's 72. Carry the 1. 42. 432. Oh. 6 times 72, I just found out, is 432. And it's got 7 left over, which is less than 72. So there should be negative 6 and 7 70-seconds. So there we go. I think, if I didn't make any mistakes, this is all of the work and all the answers. Hopefully this was helpful. Make sure you can do these on your own, and if you got any wrong or had some trouble, that you maybe try to rewrite these problems on a blank piece of paper and try them a few times again on your own until you feel a lot more comfortable. But again, all these are just a little bunch of rules that we have to put together and make sure we can make sense of it all, so that when we do more difficult things down the road, we have these building blocks to help us out. So as always, keep up the great work, and I'll see you in the next one.